Hello everyone, my name is Riaz and I'm going to present our paper titled Preserving Temporal Consistency in Video through Adaptive SLIC. The author names and their affiliations are also given here for your kind reference, and I, Riaz am going to present on behalf of the other authors. So, what is temporal inconsistency? Well, directly applying image processing techniques to individual video frames results in temporal inconsistency. And temporal inconsistency produces artifacts like unnatural tonal variations between frames or brightness fluctuations. And because of these artifacts, the quality of video is significantly degraded. Flickering artifacts may not be visible when individual frames are viewed separately. However, they will appear when the video frames are played consecutively. Also, these artifacts adversely affect video matching tasks such as motion estimation. Several researchers have proposed various methods to overcome or solve this problem. Nevertheless, existing techniques work only in specific scenarios. Therefore, we propose a multi-purpose flickering removal and spatiotemporal consistency preservation method that utilizes an adaptive SLIC algorithm. The application of adaptive SLIC algorithm creates superpixels from every frame automatically. We also propose a multi-frame matching statistical model to capture the frame that is corresponding to the other frames from temporal or spatial perspective. This slide shows the overall working of our proposed method. We first input the original video and the processed video. Then we apply the adaptive SLIC algorithm to generate the superpixels automatically. After that, we apply temporal and spatial consistency, and finally we receive the output video. Now each of these steps is discussed separately. The first step is the adaptive SLIC. The conventional SLIC algorithm is time consuming because it manually computes the number of superpixels in an iterative manner. On the other hand, we have developed an adaptive SLIC algorithm that automatically produces the number of superpixels. In our technique, we convert the RGB color space to HSV color space and use the unequal interval to quantize the HSV values and the average occurrence number to decide the number of superpixels. Second step is the application of temporal consistency. We produce an output frame denoted as P subscript X from its temporally matching frames F bracket P subscript X to preserve the inter-frame coherence. Suppose P subscript X superscript K denotes the output frame of kth iteration, then the temporal consistency term F subscript T bracket P subscript X superscript K can be calculated as shown in equation 1. Here I subscript X denotes the actual frame and F bracket I subscript X is the set of its corresponding frames. I underscore M is the matching frame of the actual frame. The terms this term and this term respectively represent the set of previous and subsequent matching frames of the actual frame. And this term denotes the temporal consistency weight. And finally, this term represents the warped output frame. Then we apply the spatial consistency. We calculate the spatial consistency for an output frame in the kth iteration as shown in equation 2. Here, A subscript x denotes the number of regions inside I subscript x or the actual frame. This term represents a region and combined with this term represent set of its all adjacent regions. To maintain the spatial consistency between regions, we decrease the difference between the output frame and its respective spatially corresponding frame. This term is an adjacent region of this term. Finally, we retrieve P subscript x by warping its spatially matching output frame. Then we apply the combined optimization. We optimize the output frame P subscript x by merging the temporal and spatial consistency terms. Equation 3 shows the objective function comprising both of the consistency terms. Here, U denotes the spatial position in I subscript x or the original frame. This term and this term respectively are the weight functions of temporal and spatial consistency terms. Next, the experimental results. We have performed experiments on two datasets named SEG-TRIG and Chen and Corso. The qualitative or visual results of our technique are shown in figure 2 that is present on the next slide. This figure shows the results of flickering removal results on the two frames of the CC video. The parts through A through C respectively denote the actual frame, the processed frame, and the result of our approach. By looking at these results, it can be observed that the neck and cheek area of girl is darker in the processed video, but our method satisfactorily removes these effects. That is all from my side. Thank you so much for listening to me.